Hello, my name is Pruthvi. I'm from BComp. Today, my seminar topic is and transmission of COVID-19 using machine learning and deep learning. Mm, for introduction, we can say that end of December 2019, Chinese government announced a few cases of COVID with unknown causes in the city of Wuhan. The outbreak originated from seafood market, infecting around 20. With study, scientists found out an infection which was caused by a novel virus named as coronavirus COVID-19. Coronavirus belongs to the Coronaviridae family in the Nidovirales order. Problem statement to determine the transmission rate and the proper diagnosis of COVID-19 to manage the situation and anticipate right diagnosis. In the literature survey, we take the following papers of K.S. Srihari Priya, a survey of mathematical and machine learning deep learning models for COVID-19 transmission and diagnosis. The entire survey contains five different models with transmission and diagnosis of COVID-19. Smart, effective, and secure healthcare systems are being developed as a top priority globally to enhance quality of life. These are the models used to detect the coronavirus. These are the compartment models. The entire population is divided in many compartments. The dynamic behavior of disease transmission is modeled as to the movement of individuals between compartments. SIR, spatial, spatio-temporal, and predator-prey model are the types of compartment models are used. First is compartment model. First compartment model is SIR model. Suspiciable infectious removed is the full form, and di by dt is equal to ksi minus ri is the formula for detecting the corona using this model. SAIR model is suspiciable exposed infectious removed. Third model is predator-prey model. In this model, prey population is assumed to be N1 and predator population is assumed to be N2. I1 group of infectious people from N1, I2 group of infectious people from N2. S1 is equal to its suspiciable group of N1. S2 is suspiciable group of N2. These are described in terms of DE, differential equation, by plotting verified data and actual data. Mm, Second, statistical models. Analysis of the effects of environmental factors that influence the spread of COVID-19 is done using statistical model. This model considers maximum relative humidity, maximum temperature, highest wind speed. Statistical model is Statistical model is generalized logistic growth model, that is dc by dt of t is equal to rc 1 minus ck. Data-driven model, using solely the patient data that has been gathered. An algorithm known as the patient information-based algorithm calculates the likelihood of death. In other words, this model uses real-time data, basic reproduction rate, and incubation period of virus make up the majority parameters that affect viral spread. The number of daily infections, which are also recorded using this model. Mm, the use of machine learning and deep learning in this model for the COVID-19 prediction. Deep learning and machine learning models are being applied globally. Vector regression and polynomial regression are two machine learning techniques that are used to predict the COVID-19 with a degree of 6 polynomial kernel. Deep neural networks and recurrent neural networks are techniques supported by deep learning. Mixed models. Next topic is mixed models. For reproduction number estimation, a hybrid modeling approach combining epidemiological equation and neural networks has been presented. Data from Wuhan, Italy, South Korea, and United States of America were used to build this model. This model outcomes demonstrate that quarantine and isolation can prevent the virus from spreading. In the conclusion, we can say that this study presents us through analysis of the existing mathematical models for COVID-19 transmission, overview of numerous models, including those based on differential equations, statistics, predictions, mixed models, machine learning, and deep learning was conducted. This survey also reviews models based on machine learning and deep learning for the diagnosis of COVID-19. The use of mathematical deep learning paradigm in computational biological and medicine is very desirable in order to create vaccination and treatment medications. It is necessary to investigate the genetics and chemistry of the virus using a deep and machine learning model. Uh, on the One of the needs for effective vaccination or medicine discovery is the deep and machine learning models. Critical use of exploring and analyzing the protein structure of viruses. Comparison of methods and technology. In that we can say that advantages of models for a compartment model, one of the simplest model and can be used for any diseases. For statistical model, it is one of the well reliable and opens with more possible analysis. Mixed model, it is highly reliable. Comparison disadvantages of the models. For compartment model, the model fails to capture sudden changes in the spreading. For statistical model, depends on the previous data, and for mixed model, highest complexity and hard to design. These are some references for more information. Thank you. This is all about detection of COVID-19 using machine learning and deep learning. Thank you.